So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, solar and storage contribute to a cheaper and more efficient electric grid. And the grid really needs help. Not just regular upgrades and maintenance, but there's more and more EV charging. It's clearly the future. And there's electrification of buildings, not to mention the resilience and the backup power we need when there's blackouts or public safety power shutoffs. Now, companies that are helping with this grid transformation really have a big market opportunity. One new company in this space is Veloce Energy, and it's my pleasure to have Jeff Wolf, CEO of Veloce, as our guest on this week's show. Now, I've known Jeff for over 15 years. Jeff was the founder and chairman of Grow Solar, the pioneering national distributor and installer of solar equipment throughout the U.S. He then did some work for retail electricity and solar providers and led him to opportunities in EV charging and grid infrastructure. Jeff and I served for many, many years on the board at the Solar Industries Association, and we worked side by side for things like the tax credits and solar favorable policy. So it's great to have you on the show. Welcome, Jeff.
Barry, it's great to be here. Great to be on here.
All right, great. You're one of our returning guests from several years ago. Now, when I was in Europe many years ago, I rented an Alfa Romeo Sprint Veloce, and then your company, Veloce Energy, uses the same cool-sounding word. What does Veloce mean? And then tell me a little bit about Veloce Energy.
So Veloce is Italian, and it means fast. So, rather than calling our company Fast Energy, we call our company Veloce Energy. Sounds a little better. So Veloce Energy is really at the intersection of transformation and electric vehicle charging. It's been a year, running the Americas for a large EV charger manufacturer and learned a lot about electric transportation. And one of the things I learned is that electric vehicle charging stations, the high-speed kind that you're building, struggle a lot to be profitable. And there's really three reasons for that. One is expensive to connect to the utility grid in many, many places and takes a long time. Demand charges in many places eat away at the revenue you do get from the station. And the total cost of installation of the systems is really quite high. The hardware is maybe a third of the price of the total installation. And so at Veloce, we're really attacking all three of those items, sort of stealthily creating grid transformation along the way. And what we're doing is combining batteries, energy storage batteries, lithium-ion batteries, with EV charging equipment to radically reduce the size of the connection needed. So if you think about a series of 50-kilowatt chargers, so the kind of the smallest fast charger you can get, puts 3 miles a minute onto your EV, basically, so 30 miles in 10 minutes. You connect, say, 4 of those on a site, and that's a 200-kilowatt connection to the grid. And that can become expensive. You connect 6 or 8 or 10, and 10 is half a megawatt connection. And that can cost upwards of $500,000 for that half megawatt connection in California. You drop that connection size in half, and all of a sudden the price plummets for your connection, and the time goes from 2 years to maybe 6 months. So by simply putting storage with the charger, you can cut that connection size, which cuts that connection cost. And it's interesting. You don't need to store hours and hours of energy to work with an EV charger, because there's times when people are charging and there's times when people are not charging. And you can charge that battery up during the non-use times and discharge the battery during the use times. And you've always got the grid there to do some amount of charging. So by combining the grid and the battery during charging periods and then using the grid just to charge the battery, you create quite a bit of efficiency in terms of your grid connection use. There's a saying in equipment about sweating the assets. And what we're doing is we're sweating the interconnection harder. We're making that interconnection work at its capacity more hours of the day so that the value we get out of that connection is higher.
So cool. It's cool because basically the cost of the batteries are less than the cost of increasing the size of the pipe from the utility into the chargers. So the value proposition is like kind of automatic.
Either less or it defers a significant amount of it. But then don't forget also, we now have half the interconnection size, which means our maximum demand is also half. So we save on demand charges as well.
So what's kind of the architecture of this? Do you guys have some server software that controls, that's going to manage all these charging stations?
So the architecture, the most important feature of the architecture, people are beginning to put batteries at EV charger stations, but they're all custom designed, bespoke designs, and they're typically using containerized batteries. And it's surprising how hard it is to get a container of batteries to fit on a charging site. People don't want to give up 2, 3, 5 parking spaces for a container of batteries that does nothing but sit there and look ugly. So our batteries are small, modular, that fit in the aisleway that the EV chargers create. Imagine you put a row of EV chargers in. Well, there's space between those EV chargers that's kind of blanked off. We put our batteries in that same space, so we're really not taking up additional footprint. And now the batteries are close to the chargers. And by distributing the batteries around the site with the chargers, you actually get a whole bunch of synergistic benefits as well in terms of conduit and cable sizing, reliability, resilience, eventually ability to tap solar and fuel cells into that grid more easily. And then finally, you get 2 added benefits out of it. You get the ability with these distributed batteries to pretty easily hook local buildings up and create resilience at almost no extra charge for these buildings. Because in an emergency situation, you decide, do I want to charge vehicles? Do I want to have a resilient building? Do I want to do both? A little bit less. But you have these batteries that you can use for multiple uses. And then finally, we'll get to the point where we have bidirectional charging. Maybe not for passenger vehicles, but certainly for yellow school buses and a lot of commercial vehicles. They're already coming. And so now imagine we have a public safety power shut off, and you've got a evacuation facility that gets shut off. Now we can actually bring in yellow school buses to this facility, tie them into this system that has bidirectional chargers and distributed storage. And you've got a long-term resilient emergency shelter without having to buy a whole lot of batteries since it's going to do nothing for 1, 2, 3, 4, 5 years.
You know, what also is very cool is you look at the pricing trends for your value proposition, and batteries are going to get cheaper and cheaper. And there's no doubt that the cost of that added grid infrastructure, that thicker wire, is going to be more and more money. And the demand charges are also going to go up and up and up. So you're riding a really good cost trajectory for your product.
No, you're absolutely right. We're on the right part of the arrow. And more than that, too, I was talking to a young California utility engineer, and he made the comment that, in his career, within his career, they would have to rebuild the entire grid. And that really stuck with me, and I started thinking about it more and more. A, we can't afford to rebuild the grid. We don't have CapEx. B, we don't have enough utility engineers to rebuild the grid in the time frames we have. And C, the way that the utility industry and the regulatory folks work is they wouldn't actually just rebuild the grid once, they rebuild the grid 3 times, because we would install an EV charging system on a distribution feeder, and they would upgrade that line to take care of that new load. 3 years later, somebody come in and put another EV charging system on it, then they need to upgrade it again. And then before we're done, they probably have to upgrade it a 3rd time. So we'd be throwing massive amounts of money at trying to solve a new problem using the old legacy ways. We've got to change the way we build the grid. And so this is why I say we're stealthily into grid transformation, because we need to make the edge of the grid, far more flexible, something you and I have been working on for a long time, Barry. But make that far more flexible. Make it easier to integrate solar, and I actually have become a believer in hydrogen fuel cells, not today, but they're coming. So we can push more and more power to the edge of the grid, use the existing asset at a higher capacity factor. Right now, the grid gets used to like 50%. We've got all these wires stamped that we should be using at 85%. So by doing this type of architecture, we get to sweat that existing asset better. So we actually believe that this architecture leads to the lowest cost for the grid upgrades we need to do to get us to 100% electrification and of transportation.
On the other hand, from a utility's perspective, they get a net return on their assets. So they want more expensive assets typically. How do you work with utilities? Are they putting this in? Are they your partners? Or is there a value proposition for them?
Well, it's really interesting because we thought quite a bit about that. And of course, when you say utilities, there's, of course, IOUs, municipals, co-ops, which are different. And then different states have different regulatory environments as well. Some are deregulated, some are regulated. So yes, in general, particularly investor-owned utilities like to have assets out that they can rate base. That's how they make their money. They don't really make their money on selling electrons. So we've got very flexible models for what the utilities can own. In some places where they're allowed to own batteries, we'll let them own the batteries. That's fine by us. Or the EV chargers, or one or other or both. Additionally, there are quite a few states where even if they can't own the battery, they're allowed to capitalize leasing payments. So when they lease them the batteries and let them capitalize the payments. So we're very cognizant that we need to work with the utilities to let them make their money, because we do need the utilities and we want them to be our partners. But it's going to vary from utility to utility and jurisdiction to jurisdiction. And certainly in munis and co-ops, they don't want capital expense.
Right. Well,
so
I think
we have a third-party ownership, or we can do OpEx to the utility to make this work.
I think what you have to do is for the utilities just raise the price more so that they can get a higher return, and then sell to some of the sell to the co-ops and the CCAs who are not working on that same model, and they're going to put the stuff in more efficiently. So that's a really big opportunity.
The biggest problem is that some of the utilities really want to do, Southern California Edison, for example, has this make-ready program. They're not allowed to buy batteries in their make-ready program. So right now, they really don't want to work with us in that particular program. They like batteries and want to work with them in other ways. But it is partially also educating the regulators and moving through the whole process as well.
Well, I think the regulators really need education and maybe some better guidance from the populace, from the citizens. I was going to say the politicians, but the politicians need that guidance too. Right. So, Jeff, how do regulators view this kind of new infrastructure of batteries going in with EV chargers, either owned or not owned by investor-owned utilities?
Well, Barry, it's a great question. And one of the real hard parts of being regulated today is that technology. Technology is changing so fast, and costs are changing so fast. So things that didn't exist commercially and things that existed commercially but were just reasonably too expensive 2 years ago are now becoming mainstream and are becoming low-cost options. So that rate of change is really hard for regulators. So regulators, remember, they regulate based upon past history largely. And California does a better job than most states do. But still, regulators are really regulating based on past history. That's the DNA. That's how they've done it for the last 100 years. So trying to stay up with that technology and not get ahead of it, because their number one criteria is trying to make reliability, which is they struggle with obviously in California. But number one is reliability, and they try and keep on doing reliability based on how they've done reliability in the past. And then, they need to change that, but they don't want to change to a new model that is unknown and untested, because that doesn't look to regulator like a model that would necessarily bring more reliability. So they're in a really tough situation. I don't envy them. I'm not sure I want to be a utility regulator right now. But I think you said it's a question of really educating the regulators. They need to be open to education and new. And, California does a pretty good job with pilots. We need to pilot new, make sure that we're always looking at new. And then any cost that they're relying on, they need to update it every year at a minimum, because the costs on batteries, the cost on power conversion are going down. We're particularly interested in DC and what we can do with DC, because so much of our world today is DC. Lighting is now DC. We just feed AC and convert it to bulb. Motors are AC, but we feed it AC and go through a variable speed drive, which puts it into a DC stage, but we feed it AC. So most building loads are already DC. Electric vehicle chargers put power into a battery, which is DC in a vehicle. Fuel cells and solar are already DC. So we need to do more and more natively DC rather than converting, because every time you convert, you lose 5 to 15%.
So just a quick question. So these 50 kilowatt chargers that you're putting in, are they DC chargers going into the DC port of the cars, or are they AC?
So they're DC chargers going into the DC port of the car. And any charger above between 7 and 20 kilowatts is going to be into the DC port of the car, because anytime you put connect an AC charger in, it has to go to an onboard charger in the car.
Right.
And that onboard charger has a size and a rating. And most cars come with a 7 to 10 kilowatt AC charger. So it doesn't matter how much AC you try and put in, they can only accept what the charger will do. Some cars have larger chargers, some trucks have larger chargers, but if you want to go into the larger power, you really need to go into the DC port. So the chargers we're putting in are DC output, but all of the chargers today, AC and DC output, have AC input.
Okay, and they may have an AC output option, but they're just going to charge at a lower speed.
Right. And so the chargers we'll be developing in our product would be a DC input charger. Because if we bring AC onto the site, convert it to DC for a battery, it doesn't make sense to convert it back to AC, put it in the charger, and then convert it to DC in the charger to go to the car. We might as well keep it as DC, maybe convert the voltage, which is much more efficient, and then put it into the car.
All these AC/DC songs from my childhood are kind of going through my head right now. Just out of curiosity, are you charging at 400 volts? Is that typically the DC voltage?
So the DC voltage in the batteries varies, depending on what car you're in, between 350 and 550 as kind of the peak voltage. Of course, when you start charging, it's lower. It can be as low as 150 volts. And then in the newer vehicles that are coming out, the new voltage is going to be 870 for the high end. They're going to high voltage battery packs. And so the range will be something like, 550 to 850 range. So
quick question. Do you have any EV now? What are you driving?
So I drive two EVs now. We drive a Tesla Model S, and we needed a second car, and our garage is not large enough for two full-size cars. So we just wanted a cheap commuter car. So we bought a used 3-year-old, 12,000-mile electric smart car.
Oh, wow.
For $6,000. It's the cheapest transportation I've ever had.
Wow. And you can
downtown,
park it anywhere.
5-mile range, and it costs me nothing.
And you can back it perpendicular to the road for a parking space. You can put two of those things in one place.
You can park anywhere. Fantastic.
All right.
Yeah.
Fascinating about the technology and the development of the grid and the policy issues that are inhibiting that. But let's talk about, from a practical standpoint, who are Veloce's customers? I mean, we're putting in solar for commercial customers, and many of these customers are asking for EV chargers, and I cringe because they're going to say, oh, I can buy a charger on Amazon for $500, and how come you're charging $10,000? $500 to $10,000 to put in like a commercial charger, not to mention all the grid stuff. So who are your target customers?
So our target customers, we've got really 5 baskets. The EV charge network companies, the Greenlots, the EV Connect, etc., are target customers for us. They will resell to corporate customers. But what they're looking for is a lower total cost of ownership for their customers. So we can offer them a lower total cost of ownership and potentially a financing option, which they don't have today, and make it easier for them to do more sales. They're really interested in that long-term operating agreement, which they can achieve. So that's one set of customers. Second set is the commercial fleets. A lot of times you'll see commercial fleets who are trying to get into EVs. They want to buy 2, 3, 4, maybe 10 vehicles. But to do that, truck depots don't have a lot of power to them coming to them usually. So you buy 10 vehicles, and all of a sudden you need to bring in your service upgrade kit. Well, that takes a couple of years and costs a lot of money. We can let them put those 10 trucks in, bring in charging, work that charging in underneath their existing connection, so they can start out using electric vehicles much, much sooner. So that's second one. Mass transit is much the same way with bus depots and such. They begin to put their toe in the water. They're ordering a few buses. They want to get them in. They want to get them going. They want the pilot to happen this year, not in 3 years. So that's another customer. And then the last customer is utilities. Utilities are beginning to deploy EV chargers as well in some states, in some places. Some states allow electric utilities to own charging infrastructure. Ameren in Missouri is one key example. So in those areas, and with municipal utilities like Austin Energy and such who are doing EV charging, bringing them a lower total cost of ownership financed option really opens up that customer base.
Wow. Well, Jeff, you and I have been side by side in the solar industry for so many years, and it's impressive that you've made this transition into the grid EV charging industry, and I really, really like the stuff that's going on in Veloce. But, in the couple of minutes we have left or so, tell me, what your view is of the solar industry, residential, commercial, utility. You're a little bit more objective now that you're not in the trenches fighting all these wars.
I don't think I've ever been called objective before. Thank you. So I walked around SPI last year, and I all of a sudden had this overwhelming feeling that solar was about to go through another stage, if you will. You and I were in it from almost the birth. And then it went through an acceleration stage and became a real industry, a multi-billion-dollar industry, investable and such. That was a transition. And the transition I see coming up now, and it's starting now, is we're going to go from being a large investable industry to being the bedrock of the U.S. economy. I believe that solar, wind, and storage are going to be for the U.S. economy what auto manufacturing, say, was for the U.S. economy back in the 50s and 60s. It's really the bedrock of the economy. And when you become that, the growth just, again, goes through the roof. And as we accelerate action on climate, as we accelerate decreased costs and just simply become the low-cost energy, and anybody who's, whether they want to act on climate or not, they want to act on low energy, we're going to accelerate at a level faster than we've experienced before, to a level higher than most of the pundits are predicting. Somebody said that when technology becomes mature, it doesn't follow a 2% per year adoption rate. Not saying we're not going to have more breakthroughs in solar. We will, and in storage. Prices continue to come down. But we're also looked at, just like in computers, we're a mature technology. And we're about to become, I think, the bedrock of the economy.
Well, and you have tentacles of solar and batteries and electrification throughout, every single component of our economy, every single industry. So, that coupled with the human necessity to reduce our carbon emissions is really, really going to make a big difference. So, all right, how can people get in touch with you at Veloce Energy?
The easiest way is email jeff.wolf with me at veloceenergy.com.
How do we spell your URL, your website?
www.veloce, VELOCE, energy.com.
All right, that's cool. I'm fascinated. I'm really, really happy for you, Jeff. This looks like a huge opportunity. That's all the time we have on this week's Energy Show, and thanks again to Jeff Wolf for joining us. And thanks to all of our listeners for tuning in. If you missed any of today's Energy Show, you can go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.